My name is Emily, as she mentioned, and today I'm going to be talking about CSS, developer experience, and how design systems can be the glue between the two. A little bit about who I am. As she mentioned, I'm a design systems engineer. I didn't know that was a job title that you could have until a couple years ago, but when I read the job description for design systems engineer, I realized those are all the things that I love. CSS, native HTML, React, bringing all of them together, and then also lots of cultural people things. So getting people to buy into a design system, getting people excited to use your components. I love all of that kind of stuff. Right now I live in Santa Barbara, California, just north of Los Angeles, and I love camping in my custom wagon and spending time outdoors with my doggo. So let's just jump right into it. CSS is hard. I'm gonna say it. I know not everybody wants to say it. By now, I'm sure you've seen all of the different Twitter arguments about this. Is CSS a language? Can you specialize in CSS? Is CSS broken, or is it written as intended? I think regardless of how you feel on the latest hot CSS controversy, I think we can all agree that CSS does require a lot of skill. So we have all kinds of things you have to deal with: z-index clashes, inheritance, cascading, reusability, accessibility, complex HTML APIs, developer experience, performance, semantics, style encapsulation, layout APIs like Flex and Grid. And then on top of that, depending on what scale your company is at, you might have totally different issues. I think a good analogy for how CSS can become complex over time is that, say you have a garden and you want it to look pretty, so you just throw a bunch of seeds onto it, and then 6 months later, all of a sudden you have this tangle of weeds and things growing over each other, and it's really hard to change one little thing because you have CSS or seeds everywhere. And I believe that design systems can help. So I just want to define design systems really quick, because I think that there are a lot of definitions out there floating around. I believe that a design system is an ecosystem of tools, guidelines, shared values, and principles which help teams more efficiently ship consistent design. So the motto would be efficiently ship consistent design. And what a design system is not is just a React component library, just CSS components, or just a style guide. So one tool doesn't make a system. It's really this collaborative effort. And at GitHub, we've got CSS components, React components, an icon library, a presentation system, which is what I use for my slides. We have Ruby components, which is a new thing that we've been working on. That's pretty cool. Interface guidelines, and Figma components. And we also have some cultural tools such as office hours, design reviews, and a system for reviewing all CSS and markup changes that ship to github.com. And when it comes down to it, a design system is a way for specialists to enable generalists, or for specialists to enable other specialists who aren't specialists at CSS. So design teams can act as experts in the field of design, CSS, UI engineering, and we make systems that make developing new features easier for the engineers and designers at your company. And we're here to make things for humans. So at the end of the day, all of this is to make customer experience better. And I think a lot of times when we talk about front-end engineering, we talk about developer experience kind of being at contrast with customer experience. So either you can have all of these amazing developer tools, but then you're gonna bloat your CSS bundle or bloat your JavaScript bundle, and it's gonna hurt customer experience. And I don't think that's really how it is. I think that developer experience enables customer experience. So in the realm of design systems, we can manage the complexity of accessibility, of complex styles, of reusability. We can write components that are super performant so that when engineers are building these things, they don't have to worry about those niche topics. And all of that creates a better customer experience. It's more intuitive, it's more performant, and it's they're getting features a lot quicker. So if it takes engineers like months to write a new UI feature, that's not a great customer experience. So they really overlap a lot. And I think that design system sits in the middle of these three things. So back to CSS land. I like to give you a little history of writing CSS at GitHub and our journey over the years trying to make the developer experience of styling UI a little bit better. So over 7 years ago, we decided we needed to come up for a solution for our growing CSS bundle. Every time we wrote a new feature, we had to ship some new custom CSS. And our bundle was actually one of our largest resources that was loading on the page. And it just wasn't efficient to write code anymore. So this is how the Primer design system was born. Initially, it was just CSS components and a style guide. And it was great. Engineers would just need to add the appropriate class names to their markup, and they'd have the styles needed to create new features. It helped us reduce the amount of new CSS shipped with every new feature, and we were able to maintain some design consistency. And our design system's called Primer. We have sort of a mix between component classes and utility classes, which you'll see on the next slide. So after a while, we started to see some drawbacks. So this is a simple form with a label, and there's a few pain points here. So you can see that this engineer or designer, at GitHub, a lot of our designers ship front-end code too, so I kind of use them interchangeably. But they had to use about, I think it's 7 different class names to get this to look just as intended. So that means there's a ton of things that the engineer needs to memorize. It leaves a lot of room for mistakes if they leave out one of the class names that they really needed to have. And we had no control over the markup. So they used a semantic label here, which was great, but they could have just as easily used a div and it wouldn't have been accessible. And as a design systems team, we had no control over that. So we took a step back and we thought, what is the ideal developer experience for authoring UI at GitHub? And we started with a list of nice-to-haves. So we wanted there to be no need to memorize class names or markup patterns. We wanted to easily update components across the code base. And we wanted the HTML and CSS to live together in the same file, like one happy family. We wanted to reduce the amount of global CSS. And we wanted to reduce the amount of custom CSS that had to be written. And so we decided that we should experiment with React. We thought that we could achieve this list using CSS and JS for style encapsulation, style props for kind of a little bit more flexibility, and theming. And so Primer Components was born. Primer Components is a React component library that implements all of the core pieces of our UI. So we've got over 30 components today, and our components manage the most complex styles involved in our UI, so that engineers and designers can spend more time thinking about the things that they specialize in, and less time trying to align stuff vertically or make things pixel perfect. So I want to go over some of the values that we had in mind when creating Primer components, which should help me illustrate how we were able to use React to create a better experience for our engineers and designers interacting with CSS. So the first one is assume that people will break the rules and provide safe ways for them to do so. So in the land of design systems and also in the land of reusable CSS, I think that there is this spectrum. On the one end, you have too much strictness, so it's impossible for users to update styles. Think of this as a React component with no props that alter anything visually, or CSS components that can be used, but you're not allowed to add any custom CSS, or you don't have any utility classes. On the other end is a system that is chaotically flexible. So that would be a system that basically allows users to change anything they want, and it's so flexible that it's not really a system. In the middle is where we want to be, which is flexibly strict. It's a term I made up when I was writing this talk. And to achieve this balance in Primer components, we're using 2 third-party libraries that we love a lot, and they're really important to getting this balance right. So that's styled components and styled system. Styled components allow us to author styles and keep those styles within only the scope of the component. And the library also deduplicates any reused styles, helps a lot with performance, and it works great in server-rendered environments, which was a must for us. Styled system allows us to expose props to the users of our components, which allow them to change utility styles such as margin, padding, and color. So to see this in action, here we've got a button component, and we can expose a font size prop. The user can pass a pixel value font size or a number that corresponds to an index in our theme. And I'll talk a little bit more about our theme next. So this is just an example of putting in a custom value if you don't want to pull from the theme. That's for the width. And then a really cool thing that they have is for M stands for margin. They also have responsive styles. So you can pass it an array, and each item in the array corresponds to a different breakpoint in your breakpoints array for your theme. So at different breakpoints, we'll have a different size margin. It's really cool, and all of this is built into these libraries, so this isn't something that we really had to implement ourselves. There's a few things that we built over it to make it a little bit more reusable for us. But yeah, so this allows the user to change these values on the fly, but stay within the constraints of our theme. So if they really want to go rogue, they can use custom values, but by providing a default theme, we nudge our users into the pit of success. So yeah, in plain CSS, we either need to have hundreds of utility classes that would bloat our style sheets, or engineers would have to author custom styles if they wanted this same level of flexibility. Our other value is to use theme values whenever possible. So whenever we're authoring component code, we try to pull directly from the theme. This way, if we need to use a new theme, such as something that's more spacious, maybe for a marketing site or a dark mode theme, all we need to do is change out that theme and the components will update automatically. So this is an example of a chunk of our theme. This is just one part of it, but you can see things like a spacing scale, a font size scale, border radiuses, and more, and it's all expressed in an object format. And this is some component code, so this is what I write to build a primer component. It's using styled components, which is this kind of why the syntax is a little different than you might be used to. But right here, we're just pulling the font weight directly from the theme and the font size directly from the theme. And then these values at the bottom, typography and common, are just saying, let this component also have these typography and common utility props. So those are like the margin and the padding props. Another value we have is that everything is a component and build for composability first. So this might seem really obvious to anyone who's been working in React for a while, but the history of front end at our company involves mostly Rails templates, lots of views that are these huge, long files, and everything's in this one file for the markup. And then CSS, I think generally sometimes we get used to like kind of throwing everything in one place. So we needed to change the mindset around building front end, and we decided, if a component is doing too many things at once, that's a good flag that it should be separated into several components. So we have sort of a range in our components. We have components that are really, really small, and they're almost kind of like utility components. That's things like box, text. We have a component that kind of abstracts the Flex API called Flex, link, position, and heading. And then we have some things on the other end, like select menu and filter list, that are kind of more like distinct chunks of UI. The last value is that a little duplication is better than overly clever code. And I think this is something that I had to learn on my journey becoming a more senior web developer. I thought as a junior developer, like, oh yeah, if you abstract things and you never duplicate anything all the time, that means you're like the best developer ever, like never duplicate anything. And in reality, that doesn't really work in practice all the time. So if you are abstracting something and that abstraction is even more hard than duplicating a thing like once or twice, you're not doing the right thing. So this value actually isn't one that we had from the very beginning. We added this later on, and it was really hard for us to stick to because we wanted to do something really unique, and we had a lot of needs that we wanted to meet. So after a while, we realized that our code base was a little bit hard to reason with, and so we did a pretty big refactor just to address this. So in conclusion, Let your design systems do the heavy lifting of complex styles. It's a great way to manage complexity, and it gives you some control over the markup, accessibility, and performance. And give your design system users flexibility, but nudge them into the right path, and I think themes are a great way to do that. And if the ideal API doesn't exist yet, go out and make it. Great tools like styled components, styled systems, CSS modules, and the like exist because someone saw a gap in how we deal with CSS on a daily basis, and they weren't afraid of taking a stab at it. Whatever you make doesn't necessarily have to be perfect for everyone. It just has to be good enough for you and your team. Thank you.